What is up, Mathletes? Welcome back to the episode of Math with Dr. Math. And today we're going to be talking about adding and subtracting rational expressions. Don't go anywhere. But first, a word from our sponsors. What do you mean we have no sponsors? All right, so let's go ahead and add these rational expressions here. All right, so notice this is a rational expression because we're adding rational expressions because we have two or more fractions, right, that we're adding or subtracting, and it's not equal to anything, right? So it's not equal to, say, another fraction. It's not equal to a constant. So this is the difference between adding rational expressions versus solving rational expressions, right? So all we're going to do is focus on adding and subtracting these. So let's jump in here. So for this first example, this is our goal. We want them to have the same denominator. So let's add that in there. So when they have the same denominator, and here we're adding, we're going to add the numerators and combine like terms. So that's what we're going to do here, right? So all we're doing is focusing on the numerator at the top. Don't do anything to the denominator. Leave it the way it is, right? So that denominator, right? So we're going to leave it the way it is. And how did I get the top? Well, all we did is we added x plus x. That gave us the 2x. And then negative 4, be careful with those signs, and positive 8 gave us positive 4 there. So just be careful with your signs and you're going to do just right. All right. So after you combine like terms and clean things up, then you ask yourself, can I factor my numerator? Can I factor my denominator? So that's what we're going to do. We're going to go ahead and factor the numerator and the denominator. And again, if you need help factoring, we have videos for you. We'll link them down below, so check those out for sure. All right, so upstairs we factor out the 2. Downstairs we could use the clown method. If you want more information, click that link down there. And there we have it. All right, what's nice about this is notice they both have an x plus 2 after you factor, right? So make sure you know how to factor, or else this process is going to be much longer, much more stressful. So just practice your factoring skills and you're going to be just fine. All right, so when we factor, boom, these x plus 2's, they cancel, right? So we divide out those x plus 2's. And so what are we left with? We're left with the 2, and we're left with the x minus 4. Some people are going to ask me, hey, Dr. Math, boom, can I cancel that 2 and the 4? Can I reduce that? This negative sign, this subtraction sign in the middle messes that up. So only when you have multiplication, right, when everything's being multiplied, that's when we're allowed to cancel. So here, this is our final answer. All right, that's making sense. Follow me to example number 2. All right, so for example number 2 here, we're going to be subtracting. All right, so what's nice, it's practically the same exact thing as when we added. Our goal is to get the denominators the same, and again we're in luck. The denominators are the same. So there's so many different ways of doing this. What I'm going to suggest here as one of our ways is we are going to distribute this negative sign. So we're going to add the opposite of the second fraction. So remember, this negative sign, all you're going to do is distribute it to the numerator. All right, so make sure you got that down. So what I did is I rewrote it, right? So we're going to distribute that negative, and when we do that, we're going to rewrite this, right? So that negative, it turns into a positive, right? Because you're distributing it, so you're changing these signs. So that's what happened there. We changed that 15 to negative 15. We changed that negative 6 to positive 6 because we distributed that negative. All right. So now we're adding. So now this becomes exactly what we did before. So let's add our numerators and combine like terms. All right, Mathletes. So let's color code this. So I got a 6x and a negative 15x, right? We're going to combine those like terms. And then we got a negative 12, and then we got a positive 6. So that's going to leave us with negative 6. All right, so let's go ahead and do that. Boom. So there's our negative 9x, because 6x minus 15x is negative 9x. And negative 12 plus 6 gave us negative 6. So all we did was combine our like terms. All right. And so we ask ourselves, now that we have this, our like terms are combined. Notice we are only allowed to do that when the denominators are the same. All right, so make sure that's in your notes. So now we factor like it's 1999. All right, so what do these two have in common? All right, we see if there's a GCF. Excuse me, so if this leading term here is negative, always factor out that negative. All right, so let's go ahead and factor out, they have a -3 in common. So we factor out a -3. So that's what we're gonna have right here. And remember, when you factor out that negative, that's gonna change your signs. So that -9 is gonna turn into +3. That -6 turns into +2. And if you're still wondering, what do you mean factor out that -3? What we're doing, right, when you factor out that -3 is you're dividing each one of these terms by -3. So -9 divided by -3, boom, 3. -6 divided by -3, bam, gives us that 2. All right, so hopefully that's making sense. All right, why did we do that? Well, we still, we want to see if something's going to cancel. And if you notice, we could also factor out a 3 from the new denominator. So if we factor out a 3 here, we're also going to get a 3 out there, and those 3's will cancel. All right, so let's go ahead and write that out. So this 3 is going to cancel with this 3. And you're going to be left with this negative that's hanging outside. All right, so again, you always want to factor as much as possible so that maybe we have some cancellation going on, and that's going to simplify our rational expression. And so what we're left with is this right here. Can you distribute the negative in? Absolutely. We're just going to leave it the way it is. All right, excellent. So now let's do one example where what happens when they're not the same. All right, what happens when our denominators are not the same? So follow me. All right, so what happens in an example like this where the denominators are not the same? All right, so first things first, we have a subtraction. So before we get into get our hands dirty, what we're gonna do is distribute that negative sign, just like we did before. So we'll change that to a positive, and then we're gonna distribute that negative. So that's gonna turn into a -x, that's gonna turn into a -1. All right, so let's do that. All right, so this is what we get when we distribute that negative sign. All right, so now that we're working with this right here, we notice that the denominators are not the same. So this is where you are going to try to factor this denominator. You would factor both if you could, but in this case, this is the only one that we can factor. So again, make sure your factoring skills are up to par, because that's gonna make this section so much easier if you know how to factor. All right, so instead of running away from it, boom, let's just practice factoring. All right, so when we factor this, we get x minus 4 and x minus 3. So we're gonna use these denominators, right? This denominator and this denominator to get our LCD, all right? And remember, our LCD is gonna be, we're trying to get both of these to be the same, both our denominators to be identical. So they both look like that LCD, our least common denominator. And again, if you need practice on the LCD, we have your back, right? So we got you every single part of the way. So these problems might seem longer and longer, but as your algebra skills get stronger, right, it's just a lot of writing. That's all it is, right? So it's not too hard, but it is a lot of writing. All right, so again, we're gonna look at these two. So I got an x minus 4, x minus 3. There's one denominator, and my other denominator of x minus 4. So my LCD here is, I want my LCD to include everything that I see here. So our LCD is x minus 4 and x minus 3. All right, so there's our LCD. And again, if you want to look more about how to build this LCD, check out the video that I have linked below. I describe it from beginning to end, and I make it really easy. All right, so I want both the denominators to look like this, right? They want to be identical. All right, so if we note, this one already has an LCD. So what I'm going to do here is, boom, I'm going to copy everything down again. But for this one, I'm going to note that it's missing from my LCD. It has the x minus 4, but it's missing the x minus 3. So that's what I'm going to multiply the top and the bottom by. What's missing? All right, so only the first fraction needs to be multiplied by the x minus 3, right? Because that's what it was missing. And you might be wondering, why do you do the top and the bottom? Well, what we're doing here is, if you were to divide these two, they'll cancel each other out and it would be a 1, right? So when you multiply anything by 1, you're not changing the problem. So right here, all we're doing is multiplying by a very fancy 1, so we're not really changing anything about this problem. All right, just in case you were wondering. So we're gonna go ahead and multiply the numerator and the denominator by x minus 3. All right, so this is where you wanna make a note to yourself, right? You only distribute the numerator, right? Only distribute what's on top. The bottom, you're gonna leave it alone, all right? And in fact, what I want you to do, because I see a lot of students make this mistake, when you distribute the numerator, make sure you put that in parentheses so you know that you're gonna FOIL, right? That you're gonna multiply that out. And so you don't make the mistake and just distribute the x. So be careful with that. I see that all the time. All right, so after you multiply and combine like terms, this is what you get from here. All right, so let me highlight it so you could see. So after we multiply, this is what we get. And in fact, off to the side, just in case you're wondering, how do you actually multiply that, right? How do you get that answer? Because I know some people are gonna be wondering, x times x is x squared. And if you could fast forward this, if you already know how to do this, x times 1 is x, negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. Combine my like terms here, so I get x squared minus 2x minus 3. So this is how we got that right there. Just in case you like to see step by step of everything that went on. All right, so this is how we got that right there. All right, so now our denominators are the same. So now we could add the numerators and combine our like terms. So x squared, it does not have a like term over here, so the x squared stays. What's negative 2x minus x? Well, that gives me the negative 3x. What's negative 3 and negative 1? That's negative 4. So again, all we did right here from this step to this step is combine our like terms, all right? And so now we ask ourselves the question, now that I have one fraction, everything's cleaned up, can I factor that numerator? Can I factor this? Yes, we can. All right, so we end up with x minus 4 and x plus 1 after you factor this. So again, if you're the person here struggling with factoring, check out that video, link below. It's really gonna help you out, all right? If your factoring skills are up to par, then this process should make sense, right? So we factor it, and this is what we're left with, x minus 4 and x plus 1. Again, the reason we factor it is because we wanna know, can we divide something out? Can we cancel? And in this case, we could cancel out the x minus 4s, and as a result, you're left with x plus 1 and x minus 3. All right, folks. So adding and subtracting these rational expressions, they can get long depending on these denominators, right? So again, the best thing that you could do as you prepare for this, as you're learning to understand this, is make sure that your factoring skills are sharp. And again, make sure you know how to find that LCD. And if you need more help, we have your back, and check out those videos. All right, so quick recap. As we go through this, first thing you do, make sure the denominators are the same, right? If not, you make them the same. After you make those denominators the same, then all you do is add what's on top, assuming it's addition, right? Combine your like terms. If it's a subtraction, distribute that negative and then combine your like terms. All right, Mathletes, so that's what we have for you today. Hopefully this video was helpful. Don't forget to drop us a like, subscribe, and we'll see you, Mathletes, in our next video. Peace. All right, Mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.